Okay guys, we are back. If you will look, we have solved absolute value equations with 2 solutions, no solutions. Now we're going to solve absolute value equations with 1 solution. So it's the same process. We want to get our absolute value bars by themselves. So if we look at this left-hand side first, there's nothing but our absolute value expression here. So we're ready to go with this. So we take our original equation, and once the bars are by themselves, you're going to set up 2 equations. So we drop the absolute value bars, set it equal to the positive, so exactly what you see, and then we're going to do the same thing. So drop your absolute value bars, and you're going to set it equal to the negative of whatever's on the other side of your equal sign. In this case, it's an expression, so we want to put that in parentheses. So now you have your 2 equations to solve. So I'm going to subtract x first so that I keep a positive x. I would then add my 2, divide, and you're going to see that x is 4. So then we're going to come to the other equation. The first thing we need to do is distribute that negative. So we'll have x plus 6 equals negative 3x plus 2 when you distribute the negative. This case, I'm going to add 3x so that my x stays positive. I would then subtract 6. So we get that x is negative 1 when you would divide by 4 there. Okay, so then remember I told you that last step is very important to check your solutions. So we're going to do that, and this time I'm going to actually write it out because it's a little more difficult when you have an expression on both sides of your equal sign to check your answer. So I'm going to write it out for you. So we had x plus 6. If I'm saying my solution's 4, I'm going to have 4 plus 6 in the absolute value bars. And then on the right hand side, we're going to substitute 4 here. So we'd have 3 times 4 minus 2. So this would give me the absolute value of 10 is equal to 12 minus 2 would be 10. And that's a true statement because the absolute value of 10 is 10. That works. Okay? Now let's check negative 1. So we would have the absolute value of negative 1 plus 6 equals 3 times negative 1 minus 2. So this will give me the absolute value of 5 is equal to negative 3 minus 2 is negative 5. Remember, the absolute value cannot equal a negative. So we're going to actually cross this solution out. And this is what's called an extraneous solution. So that word extraneous solution, I kind of think of it as like a fake solution. It appears to be when you first solve, but when you substitute back into your original, it doesn't make your equation true. So this is a to-do or a you-try problem. If you want to pause the video, give yourself a second, and then start back. I'll work the problem out and show you the steps. Okay, we are back. Hopefully you had a chance to work that one. Our expression is alone, so we can, I'm just going to copy this down, and then we can set up our 2 equations. So drop the bars, set it equal to what you see on the right hand side, and then we're going to do that again. Because it's an expression on the right hand side, we got to put a negative in parentheses with your expression. So then you're ready to solve. I'm going to add 3x here. So that's going to give me 16 equals 7x minus 12. We would add our 12 to give us 28 equals 7x. So you should have gotten the x equals 4 on that problem. Here I would distribute that negative again, so we would have 16 minus 3x equals negative 4x plus 12. So this time I'm going to add the 4x again, and that's just to keep my x positive. I would subtract 16. So we get x is negative 4. Remember that last step is important to check your solution. So when we substitute 4 back into the original, we're going to get 16 minus 3 times 4 equals 4 times 4 minus 12. So this is 16 minus 12, which is the absolute value of 4. 16 minus 12 is 4. True statement. So 4 is a solution. Now let's do negative 4. So this is really going to be 16 plus 12, which would give us 28, the absolute value of 28. Then we would have negative 16 minus 12, which would be negative 28. Again, absolute value cannot be equal to a negative. Therefore, we're going to mark this out and call this that extraneous solution. So some questions may ask you for the extraneous solution. And remember, that's just that answer that appears to be real, but is really not a solution. All right, so our last example we're going to go through is a word problem and how you apply these skills to that word problem. So it says, a meat thermometer is used to assure that a safe temperature has been reached to destroy bacteria. Most meat thermometers are accurate to within plus or minus 2 degrees. So that's important. I'm going to box this off. The ham you are baking needs to reach an internal temperature of 160 degrees. So this is our target number. If the thermometer reads 160 degrees, write an equation to determine the least and greatest temperatures of the meat. So this is asking us to write an absolute value equation, and I always start this by doing x minus what target number I'm shooting to get. So I'm wanting this to be 160 degrees to make sure that it destroys all the bacteria. So you're going to do absolute value of x minus your target number, and you're going to set that equal to whatever you can vary by. So in this case, we can vary by 2 degrees, plus or minus. So we'll set it equal to 2. So this says write an equation. We did that. Part B says solve that equation that you wrote. So our bars are by themselves. So we're going to make our 2 equations. Drop the bars, set it equal to the positive. Drop the bars, set it equal to the negative. So here we would add 160, and we would get x equals 162. Here when we add 160, we would get x equals 158. And if I sub that in, 162 minus 60 gives us the absolute value of 2, which is 2. 158 minus 160 is negative 2. Negative 2, the absolute value of negative 2 is positive 2. So both of those would work. However, in C it says, to what temperature reading should you bake a ham to ensure that the minimum internal temperature is reached? So you need to think about this. Remember, it says that we could vary plus or minus 2 degrees. So if I'm baking at 162 degrees, then my oven could add 2 degrees, which would mean it was at 164 degrees. Or it could subtract 2 degrees, which would mean I would be baking at 162 degrees. We have to reach an internal temperature of at least 160. So both of those are at least 160. If we had 158 degrees, and we were cooking at 2 degrees higher, that would give us 160 degrees. So that would work. Okay. But if we were baking at 2 degrees lower, that would be 156 degrees. This is not enough. Okay. It has to be at least 160. So we don't want to use this answer. The minimum temperature we could be baking at would be 162 degrees.